right, in this next several questions in the quiz, we're looking at this hotel marquee, and our goal is to pick out how big a round rod we need from which to hang this marquee. And by the way, a marquee is a covered structure over a building entrance, so that's why you might sometimes hear those signs above movie theaters are called marquees. It's because it's a covered structure over an entrance. So here our book is telling us all this stuff about this marquee. For now, let's just notice that he tells us it's 10 feet by 20 feet, and that the dead load and live load total up to 100 pounds per square foot. So let's go on from there. If this marquee roof is 10 by 20, let's figure out how many square feet that is, and then if the load is 100 pounds per square foot, how much is the total load? Okay, so 10 feet times 20 feet means we have an area of 200 square feet. Here we are again, we're talking about feet rather than inches. That's okay. So we have 100 pounds per square foot of load on 200 square feet, so 100 on each square foot times 200 square feet means we have a total of 20,000 pounds hanging off of these bars. That's the total load of the roof and the snow. We're looking at sizing these rods, and there are two of those rods, so notice that we have half of the load on one rod, half of the load on the other rod. So if the whole roof weighs 20,000 pounds, then half the roof weighs 10,000 pounds. Let me just point out that the way he worded the question, he tells you about how this rod is at a 30-degree angle and blah, 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 blah. So in order to figure out the force in that rod, we would need to do a little bit of trig. And we're not going to do that because it turns out that the downward load of the weight is 10,000 pounds on each side, and it's also 10,000 pounds on the rod. And if you're interested in why that happened, how do we know it's 10,000 pounds pulling on each rod, in a separate PowerPoint presentation, I think it's number 2C, I go through in some scribbly notes how you could figure that out using trig. If you don't really want to do that, that's fine. We'll just carry on. Let me just tell you that there's 10,000 pounds of force in each one of those rods. That's all we need to know. Okay, so 10,000 pounds in one rod, and he tells us that the allowable stress in that steel rod is 22,000 psi. This is the way we write it. Stress with a little subscript A stands for allowable stress. And we need to find the area of one rod. So what form of the equation do we need? By now you're probably familiar with this. We'll cover up the A. That means the form that we need is force over stress. Area is force over stress. The force is 10,000 pounds. The stress is 22,000 pounds per square inch. So that will tell you how big an area of rod you need, how many square inches you need. Just to repeat something we said last time, this triangle is just a shortcut, and if you want, you can always do algebra instead, and we looked at that last time. So covering up the A, there's the version. But to do algebra, we'd multiply both sides by A. The A's cancel out. Then we divide both sides by stress. The stresses cancel out. And we're left with A equals force over stress. Another shortcut I want to point out is that we started with our standard stress formula. Stress is force over area. And by the time we were done doing that algebra, we wound up with area equals force over stress. What the net result was is that these two terms just switched places. And this is another shortcut you can always do anytime you have three terms like this, where you have something equals a fraction. You will find that when you do all the multiply both sides and divide both sides, you will always wind up with the one by itself switching places with the one on the bottom. And that's a shortcut I like to do. Okay, so anyhow, you just found the area, and what you need is the diameter, because let's say you're writing out a parts list for this marquee, and you need to write down what size of round rod do you need to go order. Okay, so you have the area, you need the diameter. And we remember that the formula for the area of a circle is pi r squared. A lot of books use area equals pi d squared over 4. Our book does that quite a bit. Why is he doing that? Well, here's why. Radius is just half the diameter, and if you look at a circle, that makes sense. Here's the full diameter going across the circle. Half the diameter is the radius. So if you want to write it in a mathy way, radius is the diameter over 2. It's 1/2 the diameter. So if you wanted to, you could say, well, okay, so radius squared is d over 2 squared, isn't it? And what is d over 2 squared? It is d squared over 2 squared. In other words, d squared over 4. So radius squared turns out to be d squared over 4. So that means you could use area is pi r squared, or you could substitute this thing you just found and say area equals pi d squared over 4. And you can use whichever version is more convenient to you. So let's say in this problem we want to be classy and use, well, not classy. We'll just use this. I didn't mean to imply anything. We're going to use area equals pi d squared over 4. And a reason for doing that is you probably found that you need an area of 0.4545. Well, it might be handy to go from there to the diameter without an intermediate step. So we'll use the diameter, the formula that has diameter in it. So area is pi d squared over 4. We'll multiply both sides by 4, and the 4's cancel out. Now we have 4a equals pi d squared. What are we looking for? D. So to start to get the d by itself, let's divide both sides by pi. The pi's cancel out. And that leaves us with 4a over pi equals d squared. Okay, good. Now, what we want to know is how big is d? How big is the diameter? How are we going to get from d squared to plain old d? We need the square root of d. And if we do the same thing to both sides, those sides are still equal. So we'll take the square root of each side. And what is the square root of d squared? It's plain d. So d must be the square root of 4a over pi. And so you could plug in the numbers that you know. 4 times, you found the area was 0.4545 divided by pi. Take the square root of all of that, and you should come out with 0.761. Let me just say one more word here, which is about order of operations. I wish we could hold up a physical calculator and show each other. I like to I kind of overachieve with the parentheses maybe, but I really like to put in lots of parentheses to make sure I get this all right. Or the other thing I would do with this kind of equation, I would go 4 times 0.4545, enter. Then I'd go that divided by pi, enter. Then I'd go that square root of that. So just to make sure I'm taking the square root of what I think I am. If all goes well, you should come up with 0.761 as your diameter. That's great. What happens when you go down to the parts house and you say, give me some round steel rod that's 0.761 in diameter? They will say, what are you talking about? We don't sell those. So what we need now is to find a size that they actually do sell. Now it turns out that in this range of sizes, round rod is available in increments of 1/16 of an inch. So you could get round rod that was 1/16, 1/8, 3/16, 1/4, and so on and so forth. And on this slide, I have put a decimal fraction chart for you to look at, because we're trying to find a size of rod that is in increments of 1/16. And we just found that we needed a diameter of at least 0.761. All right. Well, 761 is bigger than 3/4, isn't it? So we need to look at our chart and see if we need something bigger than 3/4, what is the next 1/16 size up from that? And you can probably spot it. You will probably get to the point, if you're working in the US where we use inches, you will probably get to the point where you memorize a lot of these numbers. But for now, using a chart is a good idea.